This slidecast will cover member function overriding and member function overloading and polymorphism. Now here's a main routine. We construct a computer object and a laptop object, and then we output the my computer object using toString, and we output your computer using toString. Now when we execute that code, over here is the output that's displayed. So notice, even though your computer is of type laptop, when we called toString, we get the method that was inherited from computer. And remember, that toString method for computer, it only outputs the 4 fields that are defined in the computer class. So that method doesn't know anything about the derived class laptop, and so it wasn't able to output those additional fields. So if we want to show the state of this laptop computer instance with the data fields of screen size and weight, then we've got to define a toString member function on that class laptop. So if we go to our class laptop and we define a toString member function for it, it has the same name as a function in the computer class. Okay, that's the base class. So then we'll say the toString function in this derived class, it overrides the inherited method. Okay, and by overriding, it means when we invoke the toString method on an instance that's of type laptop, then it's going to execute the laptop sort of definition of toString, not the computer. Okay, so when we sort of redefine that toString method, that's called overriding. And here is this method now in laptop, toString, that would override the method in computer. And notice, even though laptop can't access the private data fields that are in computer, this toString method, we can invoke the toString method on the computer class. And then that's going to display the fields that this laptop class inherited from a computer. So this is sort of the kind of preferred way to do that, rather than make go to computer and make its data fields protected so that we could reference them directly in the laptop toString. We do a little bit more information hiding if we simply invoke the toString method on the computer class. Because now if for instance the computer definition were to change later and add a new field, we would immediately pick that up or represent that in the toString class for laptop. And then after it calls the computer toString method, then it appends the new fields that laptop defines. Now, if we decide to standardize and purchase laptop computers from only one manufacturer, we could introduce a new constructor that has one less parameter. So here's a laptop constructor that takes 5 parameters, and then when it initializes the computer data fields, the inherited computer data fields, it uses a default manufacturer for the manufacturer field, and then initializes the other 3 fields using 3 parameters, and then the remaining 2 parameters are used to initialize screen size and weight. So this constructor has 5 parameters instead of the 6 we originally had with laptop, because we'll use a default manufacturer. Now, the important thing here is that if we have multiple member functions with the same name but a different signature in a class, we call that member function overloading. And that applies, term applies to constructors as well. So now that we have several constructors, we've overloaded this constructor function by having several different signatures. So now both of the following statements are valid. So here's two calls where we define two variables of type laptop. And in one case we have 5 parameters for the constructor, and in the other we have 6. And that's because we have overloaded the constructor in class laptop. And in this which case, in the first case with only 5 parameters, if we don't specify the manufacturer, it'll get assigned the default manufacturer. Here's some UML diagram that shows the definition of the computer class and then the derived class laptop. And then notice we've added here this default string as part of a data field. Remember, in UML, this arrow is how we represent inheritance, where the base class, the base class computer and the derived class laptop. All right, here is the header file for computer.h, for laptop.h. It includes computer.h, and then laptop, extends the computer class. Here now is our 6 parameter constructor, and then here's our overloaded constructor with the default manufacturer. Here is our toString method, which is an example of overriding. We're overriding the string method from inherited from class computer. And then here in the private data fields we've added a constant, and notice here's another instance of this static const that we've seen earlier. There'll just be one location in memory where this value is going to be stored, and it's going to be shared by all instances of the laptop class. And here's the implementation of the laptop class, where we now see the toString method. And remember, this was the example of overriding. And then here notice in the header file we declared this default manufacturer, but we didn't initialize it, and here in the CPP file we'll give it the value mybrand. Okay, here's an example of a pointer variable, and we can use this variable. Its name is the computer, and its type is a pointer to instances of class computer. And we can use this variable, the computer, to point or reference an object of either class computer or type laptop. Because of this, remember, this is a relationship. So any derived class is also, a computer, and we can take this pointer variable and we can refer to instances of the base class or the derived class laptop. So a pointer variable of a base class is more general, can point to an object of a derived class that's specific. So laptop objects are computer objects. Okay, there is but they have more features. So suppose you purchased a laptop computer, and what happens if you do the following? You take the variable the computer, it's of type a pointer to a computer instance, and we say new laptop, and we initialize it, and we make this assignment statement, and then we call the toString method on this variable. It says, what will this function call return? Will we get a string with all 6 data fields using that laptop toString method? That's the one where we overrode the computer toString method. Or will we get just 4 data fields using the computer toString method? Well, the answer is we get just the 4 data fields. And that's because the computer, that variable, is a type pointer to computer, and so we'll invoke computer's toString method. Now in C++, there is a way for the type of the object receiving the toString message to determine which toString member function to execute. Because in this case, we get some of the information from our laptop, but since it's a laptop computer, maybe we desire to get as much information as possible. So we can do this using virtual functions. And what that means is we go back into computer.h, and here we defined this toString method, and we'll prepend, or at the start we'll put the keyword virtual. And this keyword means this method declaration makes toString to be a virtual function. A member function that's declared virtual, when it's called through a pointer or reference variable, then the actual member function will be determined at runtime. And it's based on the type of the object pointed to and not the type, of the pointer variable. Okay, so remember, let's say that again. It's when we have a virtual function, then when we have a pointer or reference variable in our program, the actual member function that's going to be executed is determined at runtime, and it depends on what that variable is pointing to, not the type of, that the variable was originally declared. So if the variable that the computer points to is a laptop, then when we see a function call, when we have a pointer, we have this arrow notation and say toString, then we can't look at it's not dependent on the type of this pointer or reference variable. It depends on the type of the instance that it points to. And with virtual functions, it will call the laptop toString function. Now that feature of virtual functions and kind of dynamically determining at runtime which method we're going to call, that's an example of a concept called polymorphism. And polymorphism is the quality of having many forms or many shapes. And it lets the program determine which member function to invoke at runtime. And so in our example, the C++ compiler cannot statically determine at compilation time which type of object the computer will point to. It might be computer, or it could be its derived type laptop. So at runtime, the program knows the type of the object that receives this toString message, and it calls the appropriate toString function. Okay, so let's look at some syntax definitions so we can see kind of the general way we do some of these things. So here's how we declare a pointer type, and the form of it is we have a type name, star, and then a variable name, semicolon. And here's an example of declaring the computer to be a variable whose type is a pointer to instances of class computer. So this variable is declared to be a type pointer to type name, so pointer to computer. And a pointer is an object, it contains the address of another object, and the reference to the object pointed to by the pointer variable, to access it, to reference it, we either use this dereferencing operator, we can say star the computer, or the pointer class member access operator. For example, the computer with this arrow. And pointers are initialized using either the address of operator or the new operator. So we can either take the address of an existing instance and assign it to the pointer, so the pointer now refers to that instance, or we use the new operator, which creates a brand new instance and it returns the address that we can store in this pointer variable. Here's the form, the syntax for creating new objects using the new operator. We can say new type name or new type name followed by an argument list, and this will determine which, these are the parameters that passed to the constructor. So here's how we can create a new computer invoking the parameter that takes invoking the constructor that takes 4 parameters. And this new operator means memory is dynamically allocated for a new object of this type, and the constructor's call to initialize the object, and the pointer to this new object is the kind of the return value of this expression. So new returns a pointer to an instance, of this type. Now, how to access an object through a pointer? Okay, we can use the dereferencing operator, and here's the syntax, which is a star followed by the pointer variable name. So here's an example, star the computer. Okay, what's this meaning? The expression, it's a reference to the object pointed to by the pointer variable. So when it's used on the right-hand side, it's the value of the object. So when we say star the computer, what's returned, the value of this pointer to the instances is an instance of class computer. And so we can assign that to this variable, which is of type computer. When we do this, my computer contains a copy of the computer object referenced by the pointer variable, the computer. So this is the dereferencing. So this variable is a pointer to a computer instance. When we say star the computer, that's referring to that actual instance. So that it's an instance of class computer, and this assignment equals operator means we make a new copy of it, and that's the value of this variable. Notice this variable isn't a pointer. My computer isn't. It's an instance of class computer. Okay, so we make a copy of it. Now here, when it's used on the left-hand side, when we say your computer, which is of class, let's say of class laptop, for instance, then the referenced object is assigned the value of the right-hand side. So we would assume star the computer, the pointer has to refer to an instance, and here we'll take the value of your computer and we'll assign it to the instance that's pointed to by the computer. Now, how to access a class member through this class member access operator. Here's the syntax for that operator, and here's some examples. So we have pointer variables, and we say arrow and toString. This accesses the member function toString. This accesses the data field RAM size, and then takes that value and assigns it to my RAM. And this takes RAM size, which is a data field in the instance pointed to by the computer, and it assigns it the value of 1024. So this member name portion, if it's a function, then the function's called. If it's a data field, then when it's on the right-hand side and is evaluated, it's the value of this data field. And when it's on the left-hand side, then the reference data field is assigned the value from the right-hand side. And this syntax with the arrow, it's equivalent to saying star pointer variable in parens and saying dot member name. But this is considered easier to read, and we can overload that operator, but we can't overload the dot operator. Now, virtual functions, remember those were used when we wanted to introduce this polymorphism so that we could determine at runtime exactly which method, which overridden method in the class hierarchy we wanted to invoke. We have this virtual keyword in front of a function declaration, or in front of a function declaration with the function body included between braces, and here's an example of that toString method. So this function declared by function declaration, it's overridden in the derived class, and if this function is called through a pointer to the base class, then the function body associated with the actual object pointed to will be executed. So if a function is declared virtual in a base class, it continues to be virtual in all the derived classes. It's good practice to include the virtual declaration in the derived classes too, for documentation purposes. Then others reading your classes, even when you come back, it'll be clear to you which functions are virtual functions. So if we have an array lab computers and we declare it, this says lab computers, and its type is a pointer to instances of class computer, then we can store pointers to 10 computer or laptop objects in this array. So lab computers is an array of pointers, and they have to point to computer instances or instances of any class that's derived from computer. Here's a for loop that we can use to display the information about each object in the array. So since our array is of size 10, we can write a for loop that iterates 10 times, and we'll call lab_computer sub I. And because the type of every entry in the array is a pointer, then we can use this operator to access the toString method of that instance. And because of polymorphism, if toString are virtual functions, then the exact type of the object pointed to determines which toString method we're going to call, either the computer or laptop. And it could vary. So we could have an array that has a mix of computer and laptop instances, and when we iterate through them, we'll get definite. Some will print out 4 parameters, and some will print out 6 or 4 fields, or 6 fields, depending on the type of the instance. Now we can define the OStream extraction operator for the computer class as follows. So we've got our extraction operator, and we take in, this parameter is a reference to a computer, an instance of class computer, and it's constant. We're not going to make any changes to this instance. And because comp is a reference to computer, we can call this method and have comp point to a laptop object. And because of polymorphism, if we declared toString to be a virtual function and we've overridden it in the derived class laptop, then depending on whether this reference points to a laptop instance or to a computer instance, that will determine which member function, which toString member function we will call. And that concludes our Slidecast.